Access databases give us lots of ways to control the input of data into the tables. This helps ensure that what we've entered is typed correctly, and often more important, consistently. Go ahead and press that button to launch the Input Mask wizard box. Go ahead and press the next button to accept the phone number property. Now we can edit the input mask if we choose. In this case, the 9s indicate that it has to be a number, but that it's optional. The 0s indicate that it has to be a number, but it's required. We can also change the placeholder character down here, and that's all the wizard needs, so we'll say Finish. Access puts the input mask down here in our phone number field, and we can go ahead and switch back to Datasheet view and test it out. I want to create an input mask that forces all of my state abbreviations to be capitalized and put in my own. I'm going to put in a description here, state abbreviation. The input mask here is going to be the greater than symbol, which indicates that everything I'm going to type in is going to be forced to be uppercase. And then I'm going to put in 2 capital L's. The L's indicate that we're only going to accept a letter. We won't be able to put in any numbers here. And Finish. It inputs the mask down here at the bottom. And now if I go back to my datasheet view, again, we'll have to save the table. Now I'll go ahead and try typing in my states again. It doesn't matter how I try typing them in, I can't get a lowercase letter here. When you have a field that will commonly contain the same information record after record, you can specify a default value to appear when entering that record. For my state, let's say I want to add a default value of the state of California, where most of my customers live. I'll go down to the default value property here and click once. Validation rules allow you to control what data gets saved in the database. If you try and enter a value that isn't allowed by the validation rule, Access will display a warning and allow you to fix the problem. We want the dates that are earlier or equal to today. That will launch the expression builder. And here we're going to type in our validation rule. I'll type less than equals to, and then the code to get today's date, which in Access is just the date function, and then open parentheses, and then a close parentheses. Go ahead and say OK. And Access adds that rule down here in our property. The validation text line is a string of text that'll show up if somebody enters an invalid record. This can be really a friendly message here, so I'm going to type in must be today's date or earlier. A lookup field allows you to select a value from a list when populating a table with information. I'm going to go to my status field here and take a look at the lookup field here. We have 2 options. We can either choose to get the lookup field values from a table or query, or we can type in the values I want. I'll go ahead and type in the values. Here we're going to type in full-time, half-time, contract, and hourly. We'll go ahead and say next. Now we can name our new field. I'm going to call this status 2. Notice that we have a checkbox to limit to list. If we leave this off, we can choose from the list or type in whatever we want. I'll turn limit to list on to prevent other values from getting entered. Now I've got the status 2 field, and when I click there, it becomes a combo box where I can select a value to populate the list. Queries are temporary looks at your data that are constructed from the records and fields stored in your data tables. A query is literally a question that you ask of the data, and the result is returned as a temporary data sheet called a record set. On the surface, and as far as the other database objects are concerned, they are tables. But as we'll see, they're simply pretending to be tables. The problem is that the tables we've created in Access are very efficient in storing data, but it also seems a little counterintuitive when it comes time to actually finding information spread between lots of tables. If, for instance, we needed to quickly find Robert Acosta's emergency contact phone number, we would first need to look up his employee ID, then take that information to the phone table, and then find his employee ID there, and finally get the number. If you have hundreds or thousands of phone numbers to look up, for a human sifting through these tables, that could be a lot of work. Luckily, we have query objects to do all that for us. Queries bridge related tables back together in whatever configuration we might need. To create a query, we simply need to write out some basic instructions on how to assemble the data. The Query Designer is a very powerful tool to have at your disposal. I'm going to right-click on it and open it in Design View. Now the Query Design environment is split into 2 sections. The upper half of the window is essentially a mini relationships map. It shows us the tables that are involved in building our query. We've got the employees table and the employees phone table. We can also see how they're related based off of the employee ID field here and here. The bottom half of the window describes all of the columns that go into creating our query. In this particular query, we have the first name column, the last name column, both of those coming from the employees table. We also have the number column and the type column coming from the employee's phone table. And I'll go to the Create tab and select Query Design. Access starts up the Query Design environment, and it gives us this Show Table window, just like when we built our relationships. From here, I can choose which tables I want to be involved in the query. I'll choose Employee Phone and press Add, and then choose Employees and press Add. Then I'll close the Show Table window. We can rearrange these tables however we'd like. I'm going to take Employee Phone and move it to the right, and then I'm going to open up the Employees table just a little bit. I'll move this window up to give me more room at the bottom. Now I just need to take the fields from our tables and move them down into the query grid. We're going to build our query using the first name and last name from our employees. Now I can click and drag first name and drop it into the first column. A shortcut way to do this is to just double click. I'll double click on last name to add it to the next column. Our third column is going to be the number from the employee phone table. I'll double click on that. And then we're going to add type. I'll double click again. At this point, this query is exactly the same as what the wizard built for us. We can check it out by running its datasheet here to see the results. And there we go. Let's go ahead and switch back into Design View. We can do a couple of additional things here in the Design View that the Query Wizard didn't allow us to do. For instance, under the Sort row here, we can choose to sort our results based off of, for instance, last name. I'll click and choose to sort ascending. I can also choose to show or hide particular fields. By default, it's going to show all the fields that you've added. But if for some reason you wanted to turn one off, for instance, you wanted to add it just to sort, but you don't need to necessarily see it, you can uncheck the Show checkbox, and that field will not display in the query's record set. I'll go ahead and turn this back on. We can also rearrange the columns once they've been put down. In order to select a column, there's this gray bar at the very top. When you hover your mouse over it, you'll get a downward pointing black arrow. Just click there to select it, and once it's selected, you can click and drag to move it to a different position. I'll click and drag last name and move it to the beginning of my query results. Finally, let me point out a really important distinction between these two buttons in the upper left-hand corner of your screen, the View button and the Run button. For most of the queries that we're going to create, they're considered select queries. They simply pull records out of your data tables. And for those, it doesn't really matter which button you press. Viewing the datasheet and running that query are exactly the same. They both display the query's record set. I'll go ahead and switch back to Design View. The only time these two buttons differ is when we're looking at append queries, the make table query, the update query, or the delete query. These are all of the action queries, and you can see the same exclamation mark in their icon. When you run these query types, which we'll talk about in later movies, those actually make changes to your database. So when those queries are active, the View button and the Run button are very different. Now we can add filtering criteria using this criteria row down in the design grid. For instance, if I'm only interested in the people that live in New York State, I can go to this criteria row and type in NY and press enter. Access wraps that in quotation marks, which is the exact syntax that it needs. I'll go ahead and run my data sheet again here, and we'll see our query record set is filtered to just the customers that live in the state of New York. Adding wildcard characters to your query criteria is perfect for those times when you want to filter your data based on a common pattern rather than an exact match. We can use this to specify criteria that displays all of the customers that begin with H by changing our criteria here from Harvey to H asterisk. When I press enter, Access updates the query to read like H with the H asterisk in quotation marks. This is simply saying that instead of exactly matching this text, we want the records that are like this pattern. It's probably best to get used to the syntax and just type it in the way that it's required, rather than relying on Access to understand your intent and fix it for you. Sometimes Access doesn't get it quite right when it tries to autocorrect. Another wildcard character at our disposal is the question mark. The question mark character stands for any single letter or number. Change the criteria to H question mark, and press enter. Again, Access updates our syntax. And now when we run this query, we'll get only our customers whose last name starts with H and has a total of 4 different characters. I'll run it, and we'll see that we only have 2 customers that meet this criteria. Let's go ahead and switch back into Design View again. We can also specify a character list as a wildcard. Simply enclose the list of characters to match inside of square brackets. Here's an example where Access won't autocorrect our syntax for you and add the like. go ahead and type in here, instead of like H question mark, type in open square bracket, ABC, closing square bracket, asterisk. Here our intent is to gather all of the last names that either begin with a B, or a C, and then any characters after it. But you'll see when you press return, you get an error message that Access doesn't understand what you're trying to do. Go ahead and say OK, and at this point we'll add in the like operator manually. I'll press the escape key to back out of it, and now I'll just type like, space, quotation mark. Now I'll type in the square bracket ABC, closing bracket, asterisk, and a closing quotation mark. Now when I press enter, there aren't any error messages, and we can run our datasheet to see the results. We'll see all of our customers whose last names either begin with an A, B, or a C. And looking at the bottom, I see that I have a total of 47 customers that meet these criteria. Adding multiple query criteria to filter your records can be accomplished in a couple of different ways. You'll notice that the line below criteria says OR. In fact, you can think of every line below as also OR lines. When you place multiple criteria on these lines, Access returns the logical combination of the two criteria. So if we move full-time from this line up here, I'll just delete over that, down and move it to the OR line here, remember to type in the quotation marks, full-time, quotation mark. If I run this query, we'll see a different result. Now I get a total of 464 employees that are either in the manufacturing department, or that are at full-time, or possibly both. Let's switch back and explore a little further. Go back into Design View. What happens if we want to display two criteria on the same field? Well, we can use the OR line in this case as well. Let's remove the full-time criteria here, and underneath manufacturing, I'm going to type quality assurance. Now I'll run the query, and we'll see just the employees that are in the manufacturing or quality assurance departments. All right, go back into Design View. There's a shortcut to writing that out on a single line using something called a logical operator, but it includes a common tripping point. Often you'll think to yourself something along the lines of, I want to see all the employees in the manufacturing and quality assurance departments. If you go to the criteria line and type that out, I'll delete quality assurance here, go back up above where it says manufacturing, and after that I'll type out and, in quotation mark, quality assurance, and press enter. If it's too long, you can enlarge the field by clicking and dragging here. So now it reads manufacturing and quality assurance. Let's run that datasheet. This time I don't get any results. So why is that? Well, if we think it through, you'll realize that you've actually asked for all of the employees that are in both departments at the same time. Obviously, that doesn't apply to anyone, so Access returns the 0 results. Let's go back into Design View. And if we change and here to the word or, so now it reads manufacturing or quality assurance. I'll click to the end and press enter. Now I'll run the datasheet, and we'll get the same results that we had when they were on multiple lines. So changing and to or is the easy fix to a common mistake. Now we get the results that we expected. There is one place where using the logical operator and makes sense. Let's go back into Design View the last time. And I'm going to add in our hire date field from the employees table to the query. Let's say that we were interested in only the manufacturing or quality assurance people that were hired in 2012. We can go into the criteria row here and type it out. I will say between and the first day of 2012, 1/1/2012, and 12/31/2012. I'll make that field a little larger so we can see the whole thing. And now we can specify a range by using and here because that makes sense in this context. Go ahead and run it, and we'll see just the 14 employees that are either in manufacturing or the quality assurance departments that were hired in the year 2012. When it comes to filtering data, there is one additional class of operators that is specifically used with numerical data. I'm going to right-click on the criteria field underneath Job Rating and select this box called Zoom. This window here will just give me a larger area to type. We can change the font size. It might make it a little easier to see. I'll change it up to 16 and say OK. The comparison operators are the less than symbol, the greater than symbol, the less than or equal to symbol, the greater than or equal to symbol, equals, and is not equal to. There. Another very powerful ability of queries is to create new columns that are calculated from the existing data columns.
In our database, we have our employee's annual salary. If I open up the employees table, we can see that over on the far right side. Here, let's go ahead and close that table. We can create a query that'll calculate the biweekly paycheck amount from that salary. I'm going to right-click on the fourth column and go to Build to launch the Expression Builder. I can also get to the Expression Builder by clicking the Builder button up here on the ribbon. I'll scroll down and I'll double-click on Salary to add that up to the expression syntax up above. Now we just need to finish the formula. I'll say divided by 26. There's 26 pay periods in a year. We'll go ahead and say OK. And Access adds that expression into our calculated field here. It gives it a name too, EXPR1, and that's not very descriptive. So I'm going to highlight that and rename it biweekly. Make sure you keep the colon after that. Now from these tables, I'm going to add in a few fields. From the States table, we're going to double-click on Region Name. And from the Orders table, I'm going to choose Receipt ID and Quantity. Now if I run this query right now, we'll see that we just get a listing of all the receipts here, which region they came from, and how many products were ordered on that receipt. Let's switch back into Design View. I'm going to change this record set now into a Totals query by pressing the button at the top here in the Show Hide group, Totals. When I do that, you'll notice a new row shows up down on the grid below, Totals here, and everything is set to Group By. In this row, we'll choose the summary statistic type that we would like to apply to each column. We want to see each of our regions, so I'm going to leave that as Group By. For Receipt ID, I'd like to see how many sales we have in each region. I'll change this to Count using the dropdown. For the Quantity, we'd like to get the total number of products sold. I'm going to change this one to Sum. Now I can actually add some additional quantity fields to get additional statistics. I'll go back up to the Orders table, and I'll double-click on Quantity 3 more times. I'm going to change their totals to Average, Min, and Max. Finally, I can include a calculated column by typing in the formula here in this last field. I'll type an open square bracket, price, closing bracket, times an open square bracket, quantity, closing square bracket. This will multiply whatever is found in the price column by whatever is found in the quantity column from our tables. From that, I can change its statistic to Sum. This will give me the grand total of all of the orders placed within the region. Let's go ahead and run this query to see the difference. We'll run it, and we'll see each of our region names. Within each region, we can see how many IDs or how many receipts have been collected within each region. I can see that the Northeast region only has 29 total receipts. The sum of quantity tells us how many products were ordered. The average of quantity, and I'll have to enlarge this to see it, tells me the average number of products per receipt. The minimum of quantity tells me the lowest number of products on a receipt. In this case, the lowest number we had was 2. The maximum of quantity tells us the most number of products ordered on any one receipt in that region. In this case, 50. And finally, we can see the total value that each region has contributed to the company, $146,000 in the Northeast region. With the totals query, I can quickly see that the Northeast region is underperforming with only 29 total sales. But I can also see that the average number of products per sale is right on track with our other regions. From a management perspective, this is a pretty valuable insight. Instead of focusing our attention on selling more products to each customer, we should focus our energies in the Northeast region on gaining more customers overall.